So we're looking at the side of the page you picked up today with the finding side lengths. So again, we're looking for a missing side length. We need to identify what we have and what we're looking at based on which angle to see do we have opposite, adjacent, or hypotenuse in order to know do I use my SO, my CA, or my TOA. So we're going to look at problems number 1 and 3 on this side of the page. I'm looking for X, which I notice is across from my right angle, so it is my hypotenuse. That means I'm definitely going to use my sine or my cosine function. I have the 30-degree angle here, and I have to identify the 12. The 12 is next to the angle, which makes it my adjacent side. So I know by looking at this problem, it's a cosine problem. I'm going to use that C equals A over H. And now I just plug in the values I have. I'm going to use my cosine of 30 degrees equals the 12 for my adjacent and the X for my hypotenuse. I always have to write down the equation so I know if I multiply or divide. If the X that I'm looking for is in the denominator of my fraction, I'm going to still have a division problem, because if I interchange the cosine 30 with the X, I'll have X equals 12 divided by the cosine of 30. I still have a division problem, and all it is number crunching at this point. So if I have my mode in degrees, I'm taking 12 divided by the cosine of 30, and that will give me 13.85. If I'm rounding to the nearest tenth, that's 13.9. That makes sense because I was looking for the hypotenuse, and it should have been a number bigger than 12. So I know I probably did that one right. If I look at question number 3, I notice that I'm given the hypotenuse. That 17 is directly across from my right angle. If I look at the 48 degrees that they've given me, the X is far away, which makes it opposite. If I have opposite and hypotenuse, I'm using that sine function. My sine is my opposite over hypotenuse. And I'm writing down the information I have. The sine of 48 degrees is equal to the X over the 17. The X is in the numerator. So to solve this equation, I'm going to cross multiply, and X will be 17 times the sine of 48 degrees. And again, it's just a number crunching to put in my calculator. I want 17 times the sine of 48. I got 12.63. If I'm rounding to the nearest tenth, that gives me 12.6. The back side of the page, the first part of this assignment just asks you to recognize, do you know what these inverse functions are? So we're going to look at those problems together. If I know that the sine of angle A is equal to X, then the inverse sine of X will equal the measure of angle A. Okay? It's an inverse, it undoes the function. If the cosine of angle A is equal to X, then the inverse cosine of X will equal the measure of angle A. I can do it with the tan function also. If the tangent of angle A is equal to X, then the inverse tan, and I write that inverse tan with a tan to the -1 power of X, will equal the measure of angle A. And we find those on our calculator using the blue inverse button. If I'm looking at the next set of problems, it's like the reteach that we just did. We have a triangle given with lengths of 3, 4, and 5. We have angle 1 and angle 2, and they want us to know in each problem, what is angle A? Is it angle 1 or angle 2? So if I look at question number 4, where my sine function is equal to my 4 over 5, and I know my sine is equal to the opposite over the hypotenuse, I have to say 4 is opposite to which angle? It's next to angle 1, so it's opposite angle 2. So in this case, the sine of angle A refers to angle 2. And so for that part of the question, you're just answering, is it angle 1? is at angle 2. On the next part of this assignment, you're just punching numbers in your calculator. We want to find the angles by just typing in the inverse button with a number. Inverse button with a number. The only one that gave my earlier classes any trouble was number 15, where I have 2 3/4 as a mixed number, and my recommendation is to make that a decimal, 2.75, and just number crunching. I want to look at question number 16 with you. This is where we're using our inverse functions in order to solve for missing lengths. If I look at question number 16, I have 4 yards for one leg, 5 yards for my hypotenuse, and they want me to find the measure of angle B and the measure of angle C. If I'm looking at angle B, the 4 is adjacent, the 5 is always going to be my hypotenuse. So for angle B, I'm looking at adjacent and hypotenuse. Adjacent and hypotenuse means I have my cosine function. So in order to find the measure of angle B, I will use that cosine to the -1 power. That means the inverse of the cosine, and I'm looking at 4/5. And so that's just number crunching. We'll look at that in just a minute to get those two answers. If I want angle C, the 4 is opposite. 5 is still my hypotenuse. So opposite over hypotenuse means I have the sine function. So I'll use the inverse sine of 4/5. And I can easily find those answers by I'm just using the inverse button in my calculator. So I'm looking at cosine inverse, which means I hit my second button, then my cosine button, and then I hit the 4/5. So that angle is 36.8 degrees. They want me to round to the nearest angle, 37 degrees. The next one, the sine, inverse sine. So I hit my second button, then my sine, then my 4/5, and my other angle, 53 degrees. So as I'm filling those in, I'm just listing that angle B is my 37 degrees, angle C is my 53 degrees, just from punching them in my calculator. The last thing that problem is asking us to figure out is what is the length from A to C. You have a right triangle with a leg of 4, a hypotenuse of 5, so you should know just by looking at it that this is a 3, 4, 5 right triangle, and your missing length is 3. If you couldn't get that from knowing special right triangles, you would use your Pythagorean theorem.